Hi peeps, this is Mrs. Tootin. Here's page 14 in the packet. I'm going to work through the answers, the types of chemical reactions here. If you remember from the last video, I just quickly reviewed the 5 types of reactions. So you could look at them here. Synthesis and decomposition kind of being the opposite of each other, and single and double replacement being very similar, and combustion involving oxygen in the reactant. So I'm going to go through, I'm going to look for just the synthesis ones, where you have just one product that got made by putting 2 things together. So, all right, so remember, you want to pay attention to where the arrow is, because the arrow means yield, because the stuff on one side of the arrow is the reactants. They're reacting together. And the stuff on the right side of the arrow are called the products, the things that are being produced or made. So I'm going to look down for one product that got made. So there we go, one product. So that's a synthesis. 2, 2, 2, 2, 2, 3, 2. There we go, one product. One thing got made. That's a synthesis. 2, 2, 2, 2. There we go, 1. That's a synthesis. You don't have to do it this way. You can just go down, but I think it's easier if you do all the syntheses at once. Here's another synthesis with the one product, and that's it. I'm going to skip from synthesis now. I'm going to look for combustion, because how many of you noticed some oxygen, and there were some in there that were also combustions. So if I go through this and look on the reactant side, if there's oxygen, not oxygen alone, I mean not oxygen bonded like that or bonded like that, I'm talking about oxygen all by itself. So there, right there, there's some oxygen all by itself. I mean, there's 2 of them, but it's not bonded to anything but itself. So this one could also be considered a combustion. There's oxygen by itself, so that's not a synthesis, so that's just a combustion. Here's some oxygen, so this could be a synthesis or a combustion. Here's some oxygen, so that's a combustion. And here's some oxygen, and so this one's just a combustion. So you can see this one is both a synthesis and a combustion reaction. So are a couple of the others. All right, let's look for the decomposition ones. Those are the ones, decomposition, when you decompose or break apart. So when you have one thing that breaks into its parts. So very first one, here we go. That's carbon dioxide breaking into its parts. So that's a decomposition. 2 things, 2 things, 2. There we go, there's another one. That's methane breaking into 2 pieces. 2 things, 2 things. There we go, there's another one. This is sulfuric acid breaking into 3 pieces. So that's a decomposition. Here's another one. That's glucose breaking into carbon and water. That's a decomposition. Here's sodium fluoride. That's a decomposition. Here's lithium phosphate breaking into 3 things. That's a decomposition. And that's it. Notice, by the way, that this worksheet at the top said you could just write the letters. But I'm writing a little bit more than just the letters. All right, let's look for single and double replacements now. Remember, single replacement is when you have a single, usually a metal, a single thing, like a metal all by itself, but then it kicks the other metal out, and then in the product side, a different metal is all by itself. So the sodium and the potassium switch places, and the potassium gets kicked out alone. Okay, so let's look for single replacements. Actually, you know, why don't we do single and double at the same time? Double is nobody's ever singly alone. They're always bonded, but it's the same kind of kicking out. All right, so this one's a double replacement, number 2. It's big and ugly looking, and this sodium and this silver switch places. So that's a double replacement. This one's also a double replacement. The barium and the sodium switch places. They change who they're bonded to. The barium was bonded to the chlorine, but now the sodium's bonded to the chlorine. So that's a double replacement. This one's a single replacement because you can see that zinc is all by itself, but it comes and it kicks the copper out, and now the copper's all by itself. So that's a single replacement. This is a typo. This G should be a lowercase g for magnesium. That confused me for a second. So here the magnesium's all by itself, and it comes in and kicks out the lead, and now the lead's by itself, so that's a single replacement. Same thing again. It's another single replacement. The magnesium's alone, but it comes and kicks out the hydrogen, and now the hydrogen's alone. So that's a single replacement. This is also a single replacement. The bromine's alone, but it's going to come in here and kick the potassium out. Oh, this is not the metal kicking. Okay, sorry. This is a non-metal. Okay, yeah, this can happen too. This is a non-metal kicking out a non-metal, so the iodine got kicked out. Okay, yep. It's a single replacement. Here we go. Another one. Cesium is a metal all by itself, and it's going to come and kick out this other metal. Kicks out the sodium. Now the sodium's alone. So that's a single replacement. Here's another single replacement. The fluorine is by itself, and it's going to come in and kick out the sulfur. So the sulfur's alone. Single replacement. And then this last one, see how big and kind of ugly it looks? Usually when they're big and ugly, they're double replacements, and this is a double replacement. So this is calcium and sodium changing places. Calcium was with bromine, but now sodium's with bromine. So this is a double replacement. All right, that's it, peeps. Email your teacher if you have any questions.